Hello.
Yes, sir.
Good morning to all the students. Up till now, we have seen gear failures, basic introduction of gears, that is classification of gears, terminology of the gears, what is the importance of machine design, all the things, basic things we have studied. Now today, we will see further part. In that first point is now gear materials. Now you are knowing that different materials are used to manufacture the gears. Therefore, we are seeing in our day-to-day life where gears are used, starting from our computer, where that CD drive is there, plastic gears are used, or in toys also, plastic gears, or that sheet metal gears, or that aluminum gears are used. Also, the sugar cane juice machine, whatever we are visiting to drink the sugarcane juice. There also you are finding the gears is used to transmit motion or power from one shaft to another shaft, and then that gears are driven by electric motor first. Therefore, that gears are made of cast iron. Similarly, you are finding the gears in two wheelers and four wheelers. In case of two wheelers and four wheelers, where exact velocity ratio we want to transmit. Therefore, there we are using alloy steel as the gear material. Why we are using alloy steel? Because it is having good strength, that is wear resistance. By allowing different elements, we are increasing the strength of the gear material or original material. Also, we are using heat treatment process so that upper surface of the gear tooth or gear teeth is hardened so that they can withstand the different forces while transmitting motion and power. Therefore, these are the some of the applications of the gears. Also, in case of four wheelers, in case of trucks and all that heavy duty four wheelers, we are finding use of gears in differential gearbox. Their bevel gears are used. Therefore, what are the desirable properties of the gear materials? First is the load carrying capacity, because these vehicles are there or these gears are there, we are using for motion and power transmission. Also, we are finding the gears in case of lathe machine, milling machine, shaping machine, drilling machine. Everywhere, wherever motion will exist, we will find gear drive. Means when the distance between shaft is small, when the distance between shaft is large, we are using belt drive or chain drive. Therefore, desirable properties of gear materials is that it should have good load carrying capacity, that is, it should have high ultimate tensile strength or yield strength. Then it should withstand fluctuating loads, that is endurance strength. Fluctuating loads means what? The load which is varying from maximum to minimum, that is known as fluctuating load. Therefore, it should have high endurance strength. Then, whenever gear are transmitting forces are acting. Therefore, there are chances that wear and tear will take place. Therefore, wear rating than strength rating decides the dimensions of gears. Allowing elements, already I have told, or allowing element grain size, percentage of carbon, surface hardness. The surface hardness is increased by using heat treatment process. Similarly, gear material should have sufficient endurance strength to avoid failure due to destructive pitting. Destructive pitting we have seen in the last lecture. Next, for high power transmission, the sliding velocities are very high and the material should have low coefficient of friction. To avoid scoring, amount of thermal distortion or warping during heat treatment. Therefore, to avoid thermal distortion or warping during heat treatment, alloy steels are superior to plain carbon steels. Therefore, alloy steels are used to manufacture the gears to avoid thermal distortion or warping during heat treatment. Now, large size gears. Large size gears, they are manufactured using gray cast iron, EFG 200, EFG 260 or EFG 350. Therefore, what is meant by this EFG 200 or EFG 260 or EFG 350? EFG means flake graphite and 200 means its yield strength. Yield strength in Newton per mm square. Therefore, EFG 200 means that material is having yield strength of 200 Newton per mm square. Similarly, FG 260 means it is having yield strength of 260 Newton per mm square. FG 350 it is having yield strength of 350 Newton per mm square. Therefore, why this cast iron is used for large size gears? Its cost is low, that is cheap in cost, less noise compared to steel gears, good wear resistance, and its drawback is it is having less strength or poor strength. Now next is case hardened steel. Case means surface. Always remember, case means surface. Therefore, best combination of wear resisting hard surface together with ductile and shock absorbing core means case hardened steel in which surface is hardened by using some heat treatment processes. There are different heat treatment processes: induction hardening, nitriding, case carburizing, annealing is there. Therefore, suitable heat treatment process is used to harden the gears. Then plain carbon steel. In case of plain carbon steel, they are used for medium duty applications. Plain carbon steels are 50C8, 45C8, 45C4. 50C8 means carbon percentage 50%. 45C8 means carbon percentage 45%. 45 again C, carbon percentage 45%. Now alloy steels. Alloy steels. Alloy steels means what? There are different alloying elements to increase wear resistance. Generally, chromium is used to increase the wear resistance. Therefore, alloy steels are used for heavy duty applications. Different alloy steels are there: 40 CR1, 40 Ni4 CR1. Now, another advantage of chromium is that it is also corrosion resistance. It is also corrosion resistance. That's why this, in case of alloy steel, chromium is used. Now next is planetary gear trains. In case of planetary gear trains, material is raised alloy steel 35 Ni1 CR60. Next material is bronze. Bronze is generally used for worm wheels. It is having low coefficient of friction, excellent conformability, also suitable where corrosion resistance is required. Drawback is its excessive cost. Now why in case of worm wheels bronze material is used? Because we are knowing that worm and worm wheel is used for the transmission of large speed reduction ratio. That is, if speed reduction ratio increases beyond 1:50 or 1:50, 1:60, due to this heavy speed reduction, lot of heat is generated. Lot of heat is generated. Therefore, that material should withstand that heat, or due to heat, thermal stresses are generated. Therefore, to withstand that heat or thermal stresses, This bronze material, due to its properties such as low coefficient of friction, excellent conformability. Conformability means what? Ability to ability to conform to the required shape. Therefore, to conform means to gain. Always remember, to conform means to gain. That's why this bronze material is used. But its drawback is its excessive cost. Next is phenolic resins, means plastic material. It is having low modulus of elasticity, work on marginal lubrication. They can tolerate errors in tooth profile. These phenolic resins or plastic material, these gears are used in computer, that is CD drive, in toys. You will find these plastic gears. Therefore, these are the materials of the gears and they are used according to their applications or where their service is required, depending upon the load carrying capacity and how much stresses they should withstand. Now next point is minimum number of teeth. Now minimum number of teeth, Z minimum, is equal to 2 divided by sine square alpha, where alpha is the pressure angle. Always remember, to manufacture the gears we require some minimum number of teeth according to the pressure angle. We cannot manufacture the gear whatever we want, that this gear should be having minimum 10 teeth. Like this, it is not there. There are some standard dimensions for the particular pressure angle. Therefore, according to that, we have to manufacture the gears. Therefore, if pressure angle is 14.5 degree, Z minimum theoretical is equal to 32, Z minimum practical is equal to 27. For 20-degree pressure angle, Z minimum theoretical is 17, Z minimum practical is 14. Similarly, for pressure angle is equal to 25 degree, Z minimum theoretical is equal to 11, Z minimum practical is equal to 9. Now, face width. Face width, we have seen its definition in case of terminology of the gears. Face width is nothing but it is the axial width of the gear tooth, or it is the width of the gear tooth measured parallel to its axis. Therefore, in the design of gears, it is required to express the face width in terms of module. In the Lewis equation, it is assumed that the tangential force Pt is uniformly distributed over the entire face width. If the face width is too large, there is a possibility of concentration of load at one end of the gear tooth due to a number of factors like misalignment, elastic deformation of shafts, and warping of gear tooth. Therefore, proper face width we have to use so that there should not be any misalignment or elastic deformation of shafts or warping of gear tooth. On the other hand, gears with a small face width have a poor capacity to resist the shock and absorb vibrations. They also wear at a faster rate. A narrow face width results in a coarse pitch. In practice, the optimum range of the face width is 8 times module less than B less than 12 times module. Therefore, face width B should be in between, or face width B should be equal to 8 times module to 12 times module. Therefore, in the preliminary stages of gear design, the face width is assumed as 10 times module. Therefore, B is equal to 10 m. We have to assume during preliminary stages of gear design. Now next, hunting of tooth. Therefore, what is by hunting? In general, hunt. To hunt means to capture. To hunt means to capture. Therefore, there is a concept of hunting tooth for uniform distribution of tooth wear. Suppose ZP, that is minimum number of teeth on pinion, is equal to 20, or number of teeth on pinion is equal to 20, and ZG, that is number of teeth on gear or number of teeth on wheel, is equal to 40. Then after every two revolutions of the pinion, the same pair of teeth will engage. The same pair of teeth will engage. Therefore, if same teeth of pair will engage, what will happen? After some time means not suddenly, maybe after 2 to 3 years, wear and tear of the teeth will take place because same teeth are coming in contact with each other. Therefore, to avoid that wear and tear of the teeth or that reliability of the gear drive should be more, what we have to do? We have to provide one extra teeth. We have to provide one extra teeth on the gear, and that extra teeth, or that extra tooth, sorry, that extra tooth is known as hunting tooth. So that what will happen when, if however we take ZP is equal to 20 and ZG is equal to here 41 should be there. Understand? The pinion will rotate 41 times before the pair of teeth will engage again. Means whatever that same pair of teeth, they are coming in contact with each other every time. Therefore, we are prolonging that time to come in contact. Because of that additional tooth or extra tooth. Therefore, this extra tooth is known as hunting tooth. Therefore, it results in more even distribution of wear. Therefore, this is nothing but hunting tooth. Now, next point is force analysis. I think all the students should draw the diagram. Now, hereafter, some expressions will be there or some formulas will be there. You have to write down that formulas in the notebook because same formulas we are going to use while solving problems. Therefore, you should not get confused at that time that from where these formulas came. Therefore, write down the title force analysis and draw the diagram. I will wait for 5 minutes. Hello. I think diagram is over. Now, first of all, we will see the diagram. This is the pinion with center O1. This center line indicates the pitch circle, and this is the gear or wheel with center O2. Pinion is the driver and gear is the driven. These two pitch circles or these two gears are in contact with each other at the pitch point. Therefore, we are observing that the tooth of pinion is in contact with tooth on gear. Therefore, whatever this line is there, this line is known as pressure line. Therefore, along this pressure line, this normal force act, normal force Pn. Why this normal force is acting? Because pinion is the driver. Therefore, when pinion will rotate first, this tooth will exert a force on the tooth of the gear, and that force is nothing but normal force, and because of that normal force gear will rotate or gear will start rotating. Therefore, this normal force is acting along the pressure line. Therefore, angle made by this normal force with respect to this horizontal line is known as common tangent. This horizontal line is known as common tangent, which is passing through the pitch point. Therefore, angle between this common tangent and normal force is known as pressure angle. Therefore, in gears, power is transmitted by means of a force exerted by the tooth of the driving gear on the meshing tooth of the driven gear. Figure shows the tooth of the driving pinion exerting a force Pn on the tooth of the driven gear. According to the fundamental law of gearing, this resultant force Pn always acts along the pressure line. Therefore, now what we'll do, we'll resolve that force Pn in two components. First is vertical component and second is horizontal component. Therefore, the resultant force Pn can be resolved into two components. First is tangential component, that is horizontal component, and next is radial component PR, or it is also known as vertical component at the pitch point as shown in the figure. Now you just see, first of all we'll see this driver pinion. This is the pitch point. Now this normal force Pn is acting like this on the pinion tooth. Therefore, this Pn is resolved into two components. PR, that is radial force. Radial, why it is known as radial force? Because this force is passing through the center of the gear. That's why this force is known as radial force. And this PT is nothing but tangential force. Why it is known as tangential force? Because it is acting tangentially on the pitch circle of the pinion. Similarly, this PT, tangential force on the gear, because it is acting tangentially on the pitch circle. This PR, radial force, it is passing through the center of the gear. That's why it is known as radial force. Always remember, radial line. Radial line means what? the line which is passing through the center of the circle is known as radial line. Same case, radial force. The force which passes through the center of the gear or through the center of circle or anything which is of circular shape, that is known as radial force. Therefore, if you will see the diagram, this radial force is acting vertically upward on the pinion and vertically downward on the gear. That's why this radial force, it is known as separating force. Why it is known as separating force? Because of this vertical force, pinion will be pulled in vertical direction, that is in upward direction, and because of this radial force on the gear, this gear will be pulled or it will be pushed in downward direction. Therefore, these two gears will try to separate with each other because of this radial force. That's why this force is known as separating force. And this tangential force PT. Tangential force PT. Now you are knowing force or tangential force into distance or force into perpendicular distance is known as torque. Force into perpendicular distance is known as torque. Therefore, since this gear is rotating, that's why torque is generated. Otherwise, force into perpendicular distance, it is also known as moment. It is also known as moment. But since gear is rotating due to this force PT and this radius of the gear, that is, we will consider that is R2 or capital R. Therefore, PT into capital R is nothing but torque, and PT into small r is nothing but torque on pinion. Therefore, the tangential component PT is a useful load because it determines the magnitude of the torque and consequently the power which is transmitted. The radial component PR is a separating force which is always directed towards the center of the gear. Therefore, the torque transmitted by the gears is given by Mt is equal to 60 into 10 raised to 6 into kilowatt, that is power. Power we have to substitute here, value of power we have to convert into kilowatt divided by 2 pi n, where Mt is equal to torque transmitted by gears in Newton mm, kilowatt is equal to power transmitted by gears in kilowatt, n is equal to speed of rotation in rpm. Now, the tangential component acts at the pitch circle radius. Therefore, Pt into d by 2. D by 2 means small r. And please try to understand. D by 2 means r or radius is equal to mt. Therefore, Pt is equal to 2mt divided by d. Therefore, from figure, again we will go back. If you will consider this figure, this is alpha, this is PR, therefore this vertical component will be also PR. Therefore, tan alpha you can write as tan alpha is equal to PR upon PT. Or from this diagram also you can see tan alpha is equal to PR upon PT. This is PR and this is PT. Therefore, from the diagram you can write that tan alpha is equal to PR upon PT. Therefore, PR is equal to PT tan alpha. Therefore, the resultant force Pn is given by Pn is equal to Pt upon cos alpha. How it came? This is the Pn. So this is the Pn, this is the alpha. Therefore, we can, since this is the right angle triangle, we can use sine, cos, tan or Pythagoras theorem to find out all these three values PR, PT and PN. Therefore, if you will consider this alpha is nothing but cos alpha. You can find out cos alpha. Cos alpha is equal to horizontal value divided by hypotenuse. This is the Pn and this is the Pt. Therefore, cos alpha is equal to Pt upon Pn. Pt upon Pn. Therefore, Pn is equal to Pt upon cos alpha. Please write down this. I think before this, you first of all draw this diagram. I will give you 5 minutes. Draw this diagram within 5 minutes. I will wait. Hello, hello, hello. I think you have drawn the diagram and you have written this. Next, write down this. Already I have explained. You have written. Therefore, next, the above analysis of the gear tooth force is based on the following assumptions. As the point of contact moves, the magnitude of the resultant force Pn changes. This effect is neglected in the above analysis. It is assumed that only one pair of teeth takes the entire load. At times, there are two pairs which are simultaneously in contact and share the load. This aspect is neglected in the analysis. The analysis is valid under static conditions, that is, when the gears are running at very low velocities, that is less than 5 meter per second. In practice, there is dynamic force in addition to force due to power transmission. The effect of this dynamic force is neglected in the analysis. Write down these assumptions and we will stop here. After writing these assumptions, please enter your roll number in chat box. Enter only one time. Thank you very much.